Okay, so today we're going to talk about single replacement reactions. We just looked at double replacement for 2 days from Wednesday and then on Thursday for the lab. So now there's something you need to know called a diatomic element. So from our previous units, you know that di means 2. So these are elements that are going to be in pairs always. And you actually have a list of these on your polyatomic chart. It says diatomic molecules. And so these are our lists. And I'm actually going to copy that list so you have it on your assignment. This is on the top of your assignment where we're doing the examples right now. So from the polyatomic chart, the list of these are H2, O2, N2, F2, Cl2, Br2, and I2. So these 7 elements are always going to be written with the 2 when they are alone. Okay, so if they're with something, you do not write the 2. But when they're by themselves, when all it says is chlorine, then you're going to write it as Cl2. If all it says is nitrogen, you're going to write it as N2. Okay, but when it's with something in a compound, you do not write it like that. So I want to show you kind of how that looks with these examples from words. So we're still going to be writing our charges and crisscrossing. But look, this says aluminum. Okay, and it doesn't say it's with anything. It just says aluminum and. Okay, so that means that I know it's just going to be Al. That's the symbol for aluminum. And is a plus sign. All right, then we have iron 2 sulfate. Okay, so I'm going to crisscross some charges here. The symbol for iron, in case you forgot, is Fe. The charge that it's using comes from the Roman numeral. It's +2. All right, and then sulfate, since it ends in 8, it's going to be on the polyatomic chart. Sulfate is SO4. The charge is -2. So then I'll crisscross. I can reduce a 2 and a 2. So this is going to be Fe parentheses SO4. Then it says yields. That's our arrow. Remember, yields, makes, produces, forms. All mean the same thing. Okay? And then on this side, we have aluminum sulfate. So we already know our symbol for aluminum is Al. But since it's with something, now it's going to have a charge. So aluminum's charge from the periodic table is +3. All right? Then we already looked up sulfate, SO4. Charge was -2. Crisscross. And you're going to get Al2 parentheses SO43. So we have Al plus FeSO4 yields, makes, produces, forms. Al2 SO43. Okay? And then the last thing says and iron. Iron is just all by itself. So it's just Fe. Things by themselves do not have a charge, including all of these. If these are alone, they don't have a charge. Only when it's with a compound, you need the charges. Okay, so now we can balance this. So we'll start with metals, in case you forgot your order, MINOH. Okay, so metals are going to be on the left side of the stairs, so that's going to be aluminum and iron. So aluminum right now on the left has 1. On the right, there are 2. Okay, so I'm going to put a 2 in front to give 2 on the left and 2 on the right for aluminums. Okay, our irons, 1 Fe on the left, 1 Fe on the right. We can move on. All right, next would be ions. That's what Mi stands for. The I is ions. SO4, remember you're going to count it as one thing, and there's no number on the outside, so there's just one of them on the left. Over here, there's 3 SO4s. Remember, this is all one thing, okay? So there's 3 of these guys. So 3 on the right, only 1 on the left. We're going to add a 3 in front. So there's 3 SO4s now, okay? But remember, when I put a number in front, that's 3 Fe's now, because this coefficient multiplies everything. That's 3 of these guys, SO4s, but now there's 3 Fe's. So I need to put a number here in front of Fe to make it be balanced. So 2 Als, 2 Als, 3 SO4s, 3 SO4s, 3 Fe's, 3 Fe's. This is going to be a 1. So your answer would be this. Okay, so after I do a second one, we're gonna fill in what identifies a single replacement reaction. Okay, same kind of deal. So we have fluorine. So fluorine, it doesn't say it's with anything. It doesn't say potassium fluoride. It doesn't have a changed ending. It's just fluorine. And when fluorine is alone, it's gonna be one of these diatomics. So I'm gonna write it as F2. Okay, then it says and, so that's my plus sign. All right, potassium chloride. So notice there's no and in between. That means this is a compound. These are together. All right, so potassium's symbol, in case you forgot, is a K. It's a +1 charge. Chloride means it's just chlorine, and that symbol is Cl. The charge is -1. So then I can crisscross, and this becomes KCl. All right, produces, that's an arrow. Remember, yields, makes, produces, forms, all mean the same thing. Okay, potassium fluoride this time. So we already looked at potassium. We know it's K. The charge is +1. Fluoride means it's together. So we're going to do F. Notice it's not F2. It's just F because it's with something. And F's charge is -1. So then I crisscross. It's a 1 and a 1. And I get KF. Okay? And then we have and. It's a plus sign. And this time, it's just chlorine. Well, chlorine is one of our 7 on this list. So when I write it alone, it's going to be Cl2. So I want to point out a couple of things. On the ones that were alone, even up here, if it was just an element, like these, or the aluminum and the iron in the previous example, you do not need the charge. Okay, you do not need the charge. The only reason the F and the Cl have 2s is because they are one of these 7. Notice Al and Fe are not on that list of 7. That list is on your polyatomic chart. It's right here. It says diatomic molecules, so you don't have to memorize it, okay? You do not need the charges when the element is alone. You only need charges when it's in a compound, okay? So now let's balance this. Start with metals. The only metal we have this time to the left of the stairs is potassium. So we have 1K, 1K, 1 on the left, 1 on the right. Okay, next is ions. Well, we don't have anything in parentheses, so we're gonna move on. Non-metals other than H or O. So that's gonna be Cl, and that's also gonna be F, okay? So on the left, we have 2 Fs. On the right, we only have 1. So I'm gonna add a 2 in front, okay? So that's 2 Fs, 2 Fs, all right? And then my Cls, I have 2 Cls on the right and only 1 on the left, so I'm gonna put a 2 in front. 2 Cls, 2 Cls. Okay, but remember this coefficient multiplies everything. So now there's 2 Ks on the left and 2 Ks on the right. So it's even. This is a 1 and this is a 1. Okay, so this is your final answer this time for this one. Okay, so what identifies a single replacement reaction? Okay, single replacement is going to have an element plus a compound on the left. So an element by itself plus a compound, element by itself plus a compound, making a new element and new compound. Okay, so you really have to know the difference between an element and a compound. An element is just by itself, okay? A compound is with something, like this. We have aluminum and S and O and all that. This is a compound as well. When it's alone, notice we didn't change any charges or anything like that. That's an element. So we had an element and a compound, and then we had a new compound and a new element on the other side. Element, compound, new compound, new element. That's how you're going to recognize a single replacement reaction. Okay, so your first 4 on your assignment are from words, like my 2 examples, and then the back are the ones where you're just going to balance. You have to be getting good at balancing. Hopefully you can get to a point to where you don't need the list as much anymore.